bit lengthy. A cylindrical container has a base of this thing. Cylindrical container has a base area of 0.9 meters square. So, and a height h. When the water pour into the container at the rate of k per second, the container fill in 22 seconds. Fill in 22 seconds. 1 cubic meters is 1000 liter, I call it. So the rate of change of the volume going to the container is equals to k divided by 1000. Okay, so these are the things per second, and the container is filled in 72 seconds. Show that k equals to 1.2 h. So you see the volume itself is what? H times A, right? So fast do this. Don't wait lah. 9.2 0.9 h. So you say it is filled in 72 seconds. So it's a constant. This is a constant. So volume divided by t equal to the speed. So what we can do is that k to 1000, okay, is divided by times 72 seconds. Is equals to 0.9 h. So you cancel here and there. The k become 12.5 h. Okay, so don't need to go and calculate. You will not wrong. So only 1 mark. The container is empty and then now pour into the container. Okay, this is a question 1. Question B. The container is empty. The water is poured into the container at the rate of kT per second. Okay. So the other one is kT per second. Where t is the time and the second when the pouring began. Find the time taken to fill the container. Okay, this is k. We know that just now k is 12.5 h. So now you need to find the equation. So this v is what? 0.9 dH dt, correct? So you see, you have a t here, then you can just mix around with the t, and you have h here, so separation variables. dH divided by h here times 0.9 12.5 equals to t dt, correct? So but this 0.9 and 12.5, you can put it become 9125. Okay, and this is ln h naught equals to t squared over 2. T is 0 initially. So initially, now there's a trick here. Can h not be 0? Find the time taken to fill the container. The time taken to fill the container means that at the rate of this kT liter per second. So you need to kT liter per second, we need to divide by 1000 again. 1000 here. Okay. Now when t equals 0, what is h? Is h ultimate So this h itself, we make a mistake. This h itself is the real h, big h. But this is the h of the height, correct? So in fact, this should be done in that manner. dv dt is equals to 12.5 big H, okay, times T. Okay, big H times T. I made a mistake already, divided by 1000. Okay, yours is K liter per second. Then, in terms of H, so now, this is dt something. So initially the volume is 0. So it is V, then we try to, the H here is a constant. So somehow you better be careful because it's quite tricky. Initially V is 0, ultimately V is V, ultimate. That means that 12.H times A initially T is 0, ultimately this is T. So this is A is 0.9 times H minus of 0 equals to 12.5 H divided by 1000 times T square over 2 minus 0. Correct? So then you notice that the H can be cancelled off. So this T itself, T is 9/125, okay, times 1000 times 2, then you put a square root here. (125) is what? 25 times 5. Correct. 25 times 5. So you have a 3 here, then you have 5 here. Then you have 1000 times 2 divided by 5. So this is 5, and this becomes 200. So ultimately your second is 3/5 times 2 times 10. So you see, I didn't even use calculator. 424. So 12 seconds. Okay, I got it not correct in the first time. So this is 3 marks only. Third question, question C. They give you that now it's empty again. The water now is poured in the container at the rate of kT plus 25. Or kT plus 75. Okay, liter per second. Then where T is the time in the second from pouring again, and the container is filled in 10 seconds. Find the height of H. So this is the condition is given to us again. So then how do we go do that? We use the same trick. dv dt equals to 1000 kT plus 25. Just now K itself, it is 12.5 H, data H. Now we're going to find H. It give us that it's filled in 10 seconds. So how many marks are 3 marks? Just now filled in 12 seconds, now it's filled in 10 seconds. How are we going to do that? This is a smart way to do that. Actually it is. So but I think smart way or not so smart way, both are the same. So this V itself is the volume. So the same thing is V minus V naught, which is 0 initially, is equals to 1/1000 times K T squared over 2 plus 25T. Correct? Because T naught is 0. So we know this 10 seconds. So then we know this V is 0.9 H equals to 1/1000 times K is 12.5 H times 10 seconds square plus 25 times 10 seconds. So you solve this equation. Very simple linear equation. You got H here. So you get the H is equals to how much? (10/11 meter). Okay, that's all. Simple, right? Not too difficult.